The galaxy Andromeda and the Milky Way galaxy are getting closer to each other minute by minute. Eventually, Andromeda will merge with the Milky Way. Galaxy M31, the second largest galaxy in the nearby group, is engaged in a collision that will take billions of years to complete. While many people consider galactic collisions to be calamity-inducing explosions, the reality is significantly more graceful, like a slow-motion dance that takes a long time to complete. Scales demonstrate that this is the case. These two galaxies have already begun their collision. As galaxies approach one another, the forces of gravity begin to restructure both systems, bringing about changes that will significantly impact the gas, stars, and other cosmic elements. When considering the universe, it's easy to imagine galaxies moving apart because of space expansion. After all, findings from the Hubble Space Telescope show galaxies moving away from one another, as distant galaxies appear to be moving toward the red end of the spectrum, a phenomenon known as redshift. However, the Milky Way and Andromeda are part of a unique circumstance. They're only about 2.7 million light-years apart, so the expansion of the universe has no effect on them. Similarly, the force of gravitational attraction between them is far stronger than the expansion of space at such close proximity. Gravity, the fundamental force that governs the universe, causes these galaxies to move toward each other at an extraordinary speed of 123 kilometers per second, approximately 76 miles per second. This swift movement is preparing both galaxies for an extraterrestrial merger that will completely transform them. While this kind of collision might sound like a catastrophic disaster, the process is considerably more gradual and graceful because the main components of galaxies, the stars themselves, are separated by vast amounts of empty space. Therefore, direct star collisions are unlikely. Instead, interactions between gas, dust, and dark matter will result in breathtaking new formations and cosmic phenomena. One of the first signs that Andromeda and the Milky Way have begun interacting is the discovery of stars with hypervelocities, stars traveling at breakneck speeds of up to 1,000 kilometers per second, fast enough to escape the gravitational pull of their home galaxies. But how do these stars reach such high speeds? Multiple mechanisms can propel stars to tremendous velocities. In binary star systems, when two stars orbit a common center of mass, one star can be perturbed by gravitational forces if the system gets too close to a supermassive black hole. One star might be pulled into the black hole, while the other is slingshot out at high speed, escaping the galaxy's gravitational grip. This process is called gravitational slingshotting, which can propel a star at hypervelocity speeds. Similarly, when galaxies collide or pass close to one another, their gravitational forces can disrupt the motion of stars, especially in dense regions where stars are packed closely together. This intergalactic interaction, specifically the gravitational forces at play, can force some stars to leave their home galaxies. Astronomers believe that many hypervelocity stars in the Milky Way may have been ejected from Andromeda. Data from missions like Gaia, which maps the positions and speeds of stars in our galaxy, support the idea that Andromeda's gravitational influence is already altering the shape of the Milky Way. As astronomers study the population of these high-speed travelers, more evidence emerges that the Milky Way-Andromeda interaction is well underway. Another sign of this interaction is found in the galaxy's halos, called galactic halos. A galactic halo is an invisible, spherical region of gas, dust, and dark matter surrounding a galaxy. Though far beyond the visible stars, halos have mass, exert gravitational effects, and play a vital role in galactic dynamics and evolution. The halo of the Andromeda Galaxy is particularly massive, extending over 1.3 million light-years toward the Milky Way and up to 2 million light-years in some regions. Despite being invisible to the naked eye, the dark matter and gas in halos exert significant gravitational effects on individual galaxies. In pioneering research using the Hubble Space Telescope, astronomers observe the light from distant quasars, extremely luminous objects powered by supermassive black holes, passing through Andromeda's halo. As this light traveled through the halo, it was absorbed by its gas and dust, revealing extensive data about the halo's structure and composition. Astonishingly, astronomers discovered that Andromeda's halo is so extensive that it overlaps with the halo of the Milky Way. This overlap indicates that the two galaxies are already in the early stages of a cosmic collision. Although the distance between their visible stars remains vast, the interaction of their dark matter and gas halos marks the beginning of a long-term, gradual merger. This finding further supports the idea that Andromeda and the Milky Way are currently engaged in a cosmic dance that will shape their futures over billions of years. The merger's effects will unfold over billions of years, beginning with their first close encounter approximately 3.75 billion years from now. As one galaxy passes through the other, their gravitational forces will distort their shapes, triggering massive bursts of star formation as clouds of gas collapse under intense pressure. This period of rapid star formation will likely produce new stellar clusters and remnants of stars, such as neutron stars and black holes. As the galaxies continue their slow-motion collision, the night sky will transform dramatically. Andromeda, which already appears as a tiny speck from Earth, will gradually grow larger over tens of thousands of years, eventually stretching across the night sky. Ultimately, the galaxy's gravitational attraction will pull them back together for a final collision in about 4.5 billion years. The most likely outcome of this merger is the formation of a new, much larger elliptical galaxy, sometimes referred to as Milkomeda. At its heart, the supermassive black holes from the Milky Way and Andromeda will merge, creating an even more powerful black hole. The combined galaxy's gas will coalesce into a completely new structure, potentially forming new star systems or ejecting some stars into intergalactic space. Our own solar system's fate is uncertain. It could be flung into the galaxy's outer regions or even expelled into the vast void of interstellar space. Despite the dramatic nature of this event, it will occur long after humanity's time on Earth has passed. Future generations of observers, or any life forms that may arise, will witness significant changes in the night sky as Andromeda and the Milky Way merge. This cosmic collision is one of the most awe-inspiring events in the universe's history, though it will take billions of years to complete. The process is already underway, as evidenced by high-speed stars and overlapping halos. While the final collision may seem like a distant event, it serves as a reminder of the ever-changing and dynamic nature of the universe. Galaxies do not remain static. They interact, merge, and reshape the cosmos in profound ways. This slow-motion cosmic dance highlights the universe's immense scale and complexity, revealing that the universe is a living, evolving entity. The merger of the Milky Way and Andromeda will forever alter the night sky, marking one of many cosmic events that emphasize the universe's vast and infinite nature. As the merger progresses over the next few billion years, the gravitational interactions between Andromeda and the Milky Way will continue to shape their evolving structures. The once distinct spiral arms of both galaxies will gradually break apart and intermingle, creating tidal tails, vast streams of stars and gas that extend into space. These tidal tails are temporary structures, formed as gravitational forces tug at the outer edges of each galaxy, flinging stars and debris into intergalactic space. During this chaotic yet graceful dance, the dense cores of both galaxies will approach each other, and their supermassive black holes, each containing millions of times the mass of the Sun, will spiral inward due to gravitational waves. As they draw closer, they will release enormous amounts of energy in the form of gravitational radiation, rippling through the fabric of space-time. Eventually, the black holes will merge, releasing a final burst of gravitational waves detectable across vast distances of the universe. This merger will mark the birth of the new galaxy's central powerhouse, a colossal black hole influencing the motion and evolution of the surrounding stars. The combined gravitational forces of the merging galaxies will also compress massive clouds of gas and dust, triggering waves of star formation. These new stars will light up the cosmic landscape, forming dense star clusters and illuminating regions of space previously shrouded in darkness. Massive stars formed during this period will live short, brilliant lives before exploding as supernovae, further enriching the interstellar medium with heavy elements essential for the formation of planets and life. Meanwhile, as the galaxies merge, their dark matter halos will also combine, creating an even larger halo that will gravitationally bind the newly formed galaxy and influence the orbits of its stars. Unlike the orderly spiral patterns of the Milky Way and Andromeda, the resulting galaxy will likely take on an elliptical shape, a common outcome of major galactic mergers. Over the following billions of years, the chaos of the merger will gradually settle into a more stable configuration. The tidal tails will fade, and stars that were ejected into intergalactic space will continue to drift through the cosmic void, forever separated from their home galaxy. Inside the new elliptical galaxy, stars will orbit the central black hole in random, three-dimensional patterns, rather than the orderly, flat orbits seen in spiral galaxies. As the new galaxy matures, star formation will eventually slow down. Much of the gas and dust that fueled starbirth will have been consumed or dispersed during the merger, leading to a decline in the creation of new stars. The galaxy will gradually become dominated by older, cooler stars, giving it a reddish hue typical of elliptical galaxies. However, isolated pockets of star formation may persist where gas clouds remain dense enough to collapse under gravity. Throughout this process, the gravitational influence of the newly formed galaxy will extend beyond its immediate boundaries, affecting nearby galaxies within its local group. Smaller satellite galaxies, such as the Magellanic Clouds, may be drawn into the gravitational well of the larger galaxy, merging with it over time. The combined gravitational forces will also affect the trajectories of more distant galaxies, subtly altering their motions within the expanding universe. Even though this cosmic event will unfold over billions of years, astronomers on Earth can already observe the early stages of this merger through telescopes. By studying the movements of stars, the shape of galactic halos, and the distribution of dark matter, scientists can piece together the story of how Andromeda and the Milky Way are slowly becoming one. Observations from missions like Gaia and the Hubble Space Telescope continue to provide critical data, allowing astronomers to refine their models of galactic evolution and better predict the future of our cosmic neighborhood. As the night sky changes over countless generations, future civilizations, if they exist, will witness a universe transformed by the union of two great galaxies. The sight of Andromeda, stretching across the sky, will become a distant memory as the stars of both galaxies settle into their new home. Though humanity may not be present to witness the final stages of this merger, our observations and understanding of this cosmic event serve as a testament to our quest to comprehend the universe and our place within it. Ultimately, the merging of the Milky Way and Andromeda is a reminder of the universe's ever-changing nature. Galaxies are not isolated islands in space. They are dynamic systems shaped by gravity, dark matter, and cosmic forces that span billions of years. As Andromeda and the Milky Way complete their cosmic dance, they will leave behind a legacy of stars, planets, and new possibilities, continuing the cycle of creation and transformation that defines the universe. Would you like me to continue even further, perhaps exploring the implications of this merger on the solar system or the future of life in the new galaxy? The blending galaxies will improve the interstellar medium, supplying the fundamentals for the stars and planets of the future, and might even include life. In addition to the formation of brand new stars, the fusion of Andromeda and the Milky Way will also most likely cause the disruption of existing stellar systems. The forces of gravity at work during the merger will pull stars out of their orbits, eject them into space between galaxies, or alter their paths. Some stars within the galaxy may even be taken over by the enormous black hole that will emerge in the middle. This chaos in a newly merged galaxy environment will make it difficult for planetary systems to remain unaffected. Gravitational disturbances might destabilize the orbits of existing planets. Another amazing feature of this galactic merger is the potential for the creation of brand new stars. Massive stars will explode when they collide, burning through their fuel more rapidly. This will result in the creation of black holes or neutron stars, dense, compact objects that contribute to the intricate gravitational landscape of the new galaxy. These black holes might merge, forming even more potent sources of gravitation, possibly releasing gravitational waves that future generations of astronomers might discover. One of these brand new stellar relics will add more value to the material in the merging galaxies, impacting everything from the movement of stars to the formation of future star clusters. The space between galaxies, other than the Milky Way, may also play a fascinating role in the merger. This intergalactic space will be crowded with chaos, a mixture of dark matter, gas, and dust. Despite being virtually invisible to the naked eye, this region will experience an increase in activity due to gas clouds being compressed and possibly heated, resulting in the development of smaller galaxies, the acceleration of cosmic rays, and phenomena such as intense supernovae. The effects of radiation and energetic events in this vast expanse of space will fuel the cosmic birth cycle, death and rebirth, fundamental to the universe's nature. The intergalactic gases and dust are especially interesting to astronomers because, as these materials are drawn into gravitational wells, they contribute to the redevelopment of gaseous environments within the merging galaxies. Some of this material may be sucked into the enormous black holes at the galaxy's centers, likely promoting the development of active galactic nuclei or quasars, luminous objects powered by the gravitational force of these massive black holes. Their brightness will be visible across the universe, offering astronomers valuable insights into the inner workings of merging galaxies and black hole expansion. In addition, the collision between Andromeda and the Milky Way will have repercussions for the cosmic structure as a whole. Both galaxies are currently part of a more extensive cosmic web of superclusters and galaxies. Their merger could affect nearby galaxies, leading to the reorganization of local galaxy groups or even the formation of new galaxies. As galaxies interact and merge within these cosmic ecosystems, they shape the universe's structure on its largest scales, providing critical insights into the nature of dark energy, dark matter, and the expansion of the universe. In the long run, the merger will create an enormous elliptical galaxy, significantly distinct from the spiral galaxies we know today. This new galaxy, commonly referred to as Milkomeda, will be a completely reorganized entity with an entire constellation of new stars, gas, and dark matter. Its shape will likely be more spherical compared to the spiral structures of the present. The merging of the Milky Way and Andromeda will mark the culmination of billions of years of cosmic change. Still, it will also raise new questions about the future of the universe. While the merger is still billions of years away, it provides a fascinating glimpse into the ever-evolving nature of the cosmos, demonstrating that galaxies are not static entities, but are constantly changing through their interactions. The result of these cosmic fusions is the ongoing reshaping of the universe, leading to the birth of new stars, the creation of galactic structures, and the continuous transformation of the cosmic landscape. The final fusion of these two galaxies serves as a reminder of the vast dimensions of space and time, offering a humbling perspective on the lifespan of our galaxy. For now, we can only admire the distant future of the Milky Way and Andromeda, aware that we are witnessing just a small moment in the vast and ever-evolving universe. As these galaxies continue their cosmic dance toward a merger, their relationship will extend far beyond themselves. The enormous gravitational forces generated by the collision will likely alter the surrounding cosmos, influencing nearby galaxy clusters. This collision might set off a chain of events, altering the trajectories of other galaxies within the local group. Some galaxies might be captured by the gravitational forces of the merging systems, incorporating their stars and matter into the growing mass of the new elliptical galaxy. Additionally, The effects on nearby galaxies will significantly impact the vast halos of dark matter that surround both Andromeda and the Milky Way. These halos, which constitute most of a galaxy's mass, will likely combine and interact in ways that could offer significant new insights into the nature of dark matter, a mysterious substance that makes up a large portion of the universe's mass, but is invisible to traditional observation methods. Understanding the behavior of dark matter during such a merger could be crucial for unlocking further knowledge about the fundamental structure of the universe and its ultimate fate. Ultimately, the merger of the Milky Way and Andromeda will mark a defining moment in the evolution of galactic ecosystems, continuing to shape the universe in profound ways.